Good afternoon, everyone.
Afternoon.
Afternoon.
Yeah. You guys have lunch already? Eh?
Yeah.
Yeah. Okay. Right. Don't forget today at 5 o'clock, about 35 minutes, 5 to 5:35 p.m. today, we have a dry run. Huh? Okay. We're
Okay.
just going to go through the process for the test later. Okay. So the actual test, if you notice in announcement in Google Classroom, is for next week. Yeah. Same. I think it's same time, same day, but next week, the actual test. Right. So you have 1 week to revise lah, to do revision. This that means after our tutorial, you have about we finish our tutorial about 4:30, right? So about half an hour, I guess, half an hour, yeah. Right, so just let me let's confirm that back. Yes, we finish at 4:30, so half an hour rest, and then we can already share the Google Meet on in our calendar, shared calendar. So that means you should see it also if you accept, yeah. Right. So it's only about 35 minutes, or maybe shorter than that. Just we just want to go get through the process only. Okay. So sort of like a dry run, dry run. Right. Okay. So getting back to today's topic, right? So we have chapter 6. Okay. And chapter 6 equivalent will be module 6 on online. The NetAcad resource should be module 6. Right. So the topic will be FHRP, right? FHRP. Now, I think by now you notice already that in a lot of the topics within this course is how to enhance your local area network. Okay, we started off with using virtual LANs, okay, for the purpose of diminishing college broadcast domains, right? And after that, we look at how that when we have VLAN, how do we allow inter VLAN routing, right? And then we start to think about, uh, providing redundancy in our network. Okay, for some networks which are mission critical means we do not want any downtime for our network, so we want to provide redundancy. Okay, but we found out that there's a problem because of the appearance of loops in the network, and layer 2 does not provision to deal with this kind of problem, right? So then we look at STP to provide the way to solve, right, by providing uh, redundancy. Okay, and then after that we look at interchannel where we want to enhance the trunk, right? Remember we learned about trunk to provide trunking between switches for multiple VLANs, but sometimes because we know that the link between the two switches will be shared, right, shared by uh, many hosts within the LAN, so we want to provide bigger bandwidth without going through costly upgrades. So we look at interchannel to provide link aggregation, right? And we look at the position of link aggregation together with STP, right? So our next topic, which is FHRP concept, is to provide similar type of enhancement to the local area network, right? Excuse me, please. Right, sorry about the interruption just now. All right, so it's again a very similar concept to enhance our local area network to allow our network to run without interruption. So you can see here it says first hop redundancy protocol. That is what the acronym FHRP stands for, right? So it all comes back to the LAN, right? Is only allow traffic inside. In order for your traffic to go outside your LAN, right, it needs to go through the first hop, which is your router, aka gateway, right? But because there's only one gateway per network, right, per LAN, so that is obviously a single point of failure. What do I mean? Well, if your router, which is the gateway, fails, and then that's it. Your LAN suddenly have no way for the traffic to be routed outside of your LAN. So first hop redundancy protocol simply means we want to provide redundancy for our gateway, for that router. We call it first hop because if you notice that every router is a hop, okay, in the inter network, right? Okay, so the first hop will be your own gateway router. Okay, and we want to provide redundancy means we want to have more than one router, okay, not operating at the same time, but becoming as a redundancy option, as a backup. Therefore, if one fails, ideally we want another router to take over the task. So this is the purpose of this chapter, to look at this FHRP. Okay, right. So on two topics, main section topic. First of all, is we want to understand what is first hop redundancy protocol, right, in more detail, and explain how that protocol operates. Okay, in terms of Hsrp, right? As usual, whenever we have this kind of protocols, there's always going to be proprietary versus open standard. So we're going to look at what is Cisco providing and what are the options besides Cisco, right? Cisco also is compatible usually with open standard. That's the only way that you can get both market, the market that maybe is vendor specific, right? Have no problem having Cisco as their sole vendor, but Cisco also want to capture the market where the organization is multi-vendor. So usually you see that a lot of Cisco's devices are basically multi-vendor. Right? So they support not only their own protocol but other protocols itself, as well the open standard protocols. Right? So let's go to the first section. Okay, to explain what is this first hop redundancy protocol. Okay, let's look at the concept. Right. So before we see the solution, let's look at the problem. Okay, what is the problem? Okay, as far as we know until now, when we think about router, we can picture in our mind that every LAN must have one router, right? And that is actually very sufficient, right? Very sufficient already, because we only need one router, and that router forwards traffic within the LAN to the outside network, and vice versa, receiving outside traffic into our own local area network. So when we do configuration, you see that all of the configuration for host devices or end devices only have a single field for gateway IPv4 address, even IPv6 address. Single, right? You never see multiple, right? Okay, at least DNS you have two. One is the main one, second is the fallback. But for gateway, you only have one field, which means uh, the way it works is that gateway, there must always be only one gateway. So imagine your castle, in order to prevent, a breach of the walls, but you still need to go out, right? You only have one main door, one main gateway where you can go in and out. Okay, and that's it. And usually we see the typical movie plot where if you have a lot of times enemies will use another side entrance to gain entry, right? Side entrance to gain entry, and yeah. So coming back to gateway, there is no configuration where you have uh, multiple gateway address, only one, right? But then we encounter this limitation, which is very obvious. If that gateway interface fails, the router, something wrong with it, it just fails or it just what lah, doesn't work anymore. Then the entire LAN now that is depending on that router to provide access to outside of your LAN now cannot, right? The traffic inside the LAN still works because traffic inside the LAN depends on the switch. But the moment your host trying to communicate outside of the LAN, and because of the router being down, the gateway router being down, then no traffic can go out or in, right, into the network, right? So you might say, why don't we just put another router? Well, the thing is, yes, you can, but then the router will not be seen by the host. Remember again the single field, because that is the way it was configured earlier on. I mean, the way we use routers, LANs, and internet was designed earlier on. This was the way it was designed, right? So even if you have another router, okay, what needed to be done is, if without the first hop redundancy protocol, is the system administrator will have to, if it's static, static configuration, will have to go into every host or every workstation to change the address. And that is, and you cannot have one router, two or more routers having the same IP address on the interface, right? You cannot have that because then duplication of IP address. Therefore, you have to go into to configure every one of that without this FHRP. You have to go to every host, change the IP address for the gateway to go point to the new router's IP version or address because the other one just failed. Right, and this is probably achievable for small network, but still tedious, right? But it's for large network. This is there's too much. It takes time. It's disruptive and it takes time, and it fails the purpose of critical system requirement where if you don't need, you don't want to have any downtime. So they come up with this FHRP, stands for First Hop Redundancy Protocol, or FHRPs. These are the protocols that we'll look at the configuration later, but should automatically provide a transparent switch. And this the mechanism that we see we can provide to avoid the system administrator to go and change all the gateway IP address, right? To provide a transparent switch. Transparent because it's automatic, and the users that typically on the host in the network doesn't even know that it's happening or there was a failure, right? Transparently, if one router falls faulty, the other, which is a standby router, simply takes over. Okay. All right. So this is the benefit of having this protocol, first hop redundancy protocols. Okay. Any questions so far?
No.
Can only have one default gateway.
Yeah, you can only have one default gateway. That is how the network was designed from early on.
Okay.
All right. They probably can redesign, but then it will involve a lot of changes. That is very disruptive to, because it's already deployed over organization or whatever using already focus, and even manufacturers only focus on like single gateway, right? So the best way to provide is to provide these FHRPs. Okay, so that means it is working on top of the current single gateway limitation. So it's actually very clever. We are talking about virtualization of the gateway address, right? So we'll talk about that, yeah. Right here, right. So what I was talking about is this. This is the clever thing about it, right? So if we are tied to a single router, and it's very troublesome for us to reconfigure all the hosts to point to a different router, because the default router is down. You want the backup router, but then due to IP version 4 address must be unique, you cannot have two routers to have duplicate IP address. So instead, put a layer in front of the multiple routers. How many routers do you want to have as backup? And put a layer in front, which is a software layer, and the software layer project an image of a virtual router. So all the hosts, okay, inside that LAN sees that virtual router. That virtual router will have that IP address, and that IP address is the gateway address for all the hosts. So to provide the functionality of that virtual router, right, then you can have many routers at the back, right? We'll see that, first of all, we discuss about one default router, okay, providing functionality for that virtual router, and the rest of the backup router simply just waiting to be called. All right, just in case that default router down, straight away, transparently, yeah, right, the other router, backup router, would then take the load, okay, to handle the functionality of the virtual router, right? So this is the clever part, right? The clever part. Now there's later on we'll just touch on another type of protocol where instead of having one router, okay, providing functionality for that virtual router, since that is virtual, with some clever programming, system programming, right? You can actually do load balancing, right? So you have, well, why do we just leave the backup routers not doing anything, just waiting there, right? Okay, we want to make full use of our investment, so why not load balance? Load balancing means to share the job, right? So during a heavy period when a lot of people are doing communication going out, so the virtual router will get every traffic, but then, right, the protocol distribute the workload to the available routers. So you can think of all the available routers as the gateway, the actual physical gateway. But we 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 only want one gateway to represent those routers, which is the virtual router. So you can see here is the explanation. The router redundancy means behind the virtual router, the physical router that's doing the job. Of course, you have more than one already. So that's where the redundancy comes in. And since it's the host doesn't see those physical routers, they only see the virtual router, which is virtual is the software image as being shown. To the host, it's as if, right? It's as if they see only one gateway because there's only one IP address, right? That's the illusion created by the virtual router. Okay, but actually behind there are the physical routers that takes over the job of providing functionality by the virtual router, right? So you can see by sharing an IP and MAC address, they share because they all relate to that virtual routers. This virtual router interface has IP and MAC address, consistent. So all these routers acts as a single virtual router. Okay, so that means the virtual router's IP version 4 address is the address used to configure the gateway address on all the hosts within that LAN. Right? Okay, so let's say host devices, the frames are sent from them to the default gateway. Right? So the hosts use ARP to resolve the MAC address that is associated, because because they only have IP version 4 address, in LAN, yeah. Without the MAC address, they have to send out ARP. The ARP will be sent a broadcast. One of it will reach the virtual router. Of course, the virtual router detects, oh, that IP address is actually my IP address, because I am the gateway IP address. Then I will return back by MAC address. The MAC address is actually an IP address is consistent for that interface on that virtual router, right? Okay, right. So basically, if you think about traditional, you have one physical router, right? Using this FHRP, you're basically replacing that single router with virtual router. But virtual router is software, right? You still need the real router. So the real router, it works behind the scene, right? Behind the scene. Okay, so you can then configure physical router to work with the FHRP. All right. Okay. Right. So the protocol that is used is actually the FHRP, the first hop redundancy protocol. It is used to identify, there might be 2 or more routers depending on the size of the network and your budget, right? You can have 2, right? One backup, one active, or you can have more, just in case you say, oh, if both fail, at least I have the third one, right? Okay, right. So host device sends traffic to the address of the virtual router, because we use the IP address of the virtual router and MAC address of the virtual router as the one that as we configured on the host, right? And then the physical router working behind the scene is transparent. None of the hosts even know that the IP address belongs to a virtual router. To them, it's business as usual, right? Because they know there's a gateway, there's an IP address, gateway IP address, right? So whenever they need when they look at the ARP table, right? Then it works normally. Okay, they don't even know that there's multiple physical router working behind, or how many routers that is providing redundancy, and there is basically a virtual router working. Okay, it's transparent, so that's the good thing. That means it's an excellent way to provide functionality, because it does not change how network operates currently, right? It accepts that the current way for networks to work is this, and then so I will provide the router gateway redundancy, okay, but it still transparent, mean there is no other changes need to be done apart from the router part. Okay. Okay, so the protocol, what does the protocol do? Well, there must be a mechanism, okay, to determine which router is the active router. That means the one that is actively providing the functionality for the virtual router, right? So that means they need to have a way to communicate, to say who becomes the active, who will become the backup, right? And this protocol must also work when one of the router, maybe it's the active router, goes down. So the protocol must provide a way to say which one among the, if you have more than two, right? Which one among the remaining router becomes the next active router, right? And let's say you bring in another router, okay? So the protocol must be aware also, oh, there's another router going to provide redundancy. So whether you remove router, add router, okay, change the active router to which one, the protocol has to be able to do all these things, right? So you can see the third point there, the ability of the network to dynamically recover. Means it doesn't have to follow a systematic, it can be anytime. Anytime there's a failure of a device, the network can self-recover in terms of changing which router becomes active after that. So the gateway mechanism continues transparently, okay, whereby the host didn't even realize there was a router failure, okay. Right, so this is one of the requirement for the protocol earlier that I mentioned, because there's always one active router providing the functionality for the virtual router. When the active router fails, the redundancy protocol, right, will somehow transition or change the status of standby router, those waiting for their turn, to become the new active router, to take over the role of the failed router, right? So the steps goes by like this, yeah. The standby router stops because the active router has failed, so it's not able to function, right? Okay, if it's not failing, it should be periodically sending hello messages. Hello messages here is a way to let other router know that, okay, I'm okay, I'm an active router, okay, I'm okay. So it's periodically for the active router to inform the other routers. We call this hello messages, and it's part of the protocol, right? But when as the active router fails, I stop sending message, and the other routers will notice this. Therefore, if they start to notice the active router is no longer sending hello messages indicating something has gone wrong, then the standby router will assume the role, straight away take over the job of providing functionality for that virtual router, right? And because it's worked transparently, there's no IP version 4 address change, because it still remains the same. The virtual router, okay, still have the same IP and MAC addresses. It's just that the active router is no longer serving that virtual router. Now the standby becomes the active. Okay?
So
Right.
So that means the default router failed and then it changed to another router.
Yeah, the default router here, we call it the active router lah.
Oh,
Yeah.
but the default router is still the same, but they just switch to another router.
Yeah. So now with many routers, I think the best way to describe this, the default router is should be the virtual router, right? So which physical router providing the functionality, that means it's actually doing the work of the virtual router. should be the active router. Then the others are standby routers. They don't do any work. They just wait until perhaps the active router is faulty and goes down. Then they notice there's no more hello messages from the active router. Then they will the standby router will take over, right? Will take over the job lah. So that then the standby router becomes the active router. Now there is if you have more than two, right? So we have a way to differentiate. How do we know which of the standby routers, or in the beginning more than one router, which of the router becomes the active router, right? We'll see later how is that determined, right? But through this mechanism, FHRP, the active router takes over. I mean, it is an active router, and then if it goes down, the standby router will take over the job, because how does it know? Because no more hello messages, right? So I assume that, oh, you've gone down, so I'll take over your job, right? But these are all behind the virtual router, happening behind the virtual router, right? Okay, I'm giving you an idea that what is presented is the virtual router. So the host C, the virtual router. But the virtual router, to us, because we just want to differentiate between, there's no real one router. There are multiple routers actually providing the routing service, but only one at a time. Okay, to provide transparency, what the host sees is some illusion of a single router, which is we know is a virtual router. Okay, so from the host point of view, still like any normal network, the single router, single IP address, single MAC address to represent the gateway address. Okay, but here we're saying that the provision is by using FHRP, right, is virtualizing the router. Okay, we cannot change the way the network works. So what we do is, yes, we only need one router, default router. So the default router, replace it with the virtual default router. Okay, so how to provide the functionality, because it's a virtual router, okay? Still need to do the job of forwarding packets. So we have active routers, because multiple routers, active, standby. Standby don't do any work, active do the work. When active goes down, one of the standby routers become active, right, to replace. And this work transparent, right? They just spring into action when they see no more hello messages. Okay, that's my queue. I become active router. I take over the job, right? Right. So the packets coming into the virtual router will be redirected to that active router, no longer to the down previously or X active router. Right. So let's have a look at this first hop redundancy protocol. So the Cisco version, right? Cisco version, the proprietary version that is provided by Cisco, is called Hsrp, or Hot Standby Router Protocol. Okay, if you're confused about the acronym, I don't blame you. Okay, in computing, we love our acronym, right? So for FHRP is a name to give as a general umbrella. Okay. Okay, so FHRP does not say, oh, just Cisco. There are many. So in general, we call them the first hop redundancy protocols, right? So one of these protocols, okay, that does this job is the one that is from Cisco. And we know from Cisco must be proprietary. And it's called by Cisco, it's Hsrp, which is Hot Standby Router Protocol. Right? An implementation of FHRP by Cisco. And Cisco also have another version that is catering for IP version 6, which they call, funny enough, Hsrp for IPv6, right? So you can see this one for IP version 4, this one for IP version 6, right? Okay, so what about the open standard? The non-proprietary, yes, they also have. For them, the implementation of FHRP is called VRRP version 2, or Virtual Router Redundancy Protocol version 2. This one is non-proprietary. It does not belong to Cisco or any other companies. This is the open standard version, non-proprietary, right? Okay. So, but at the end of the day, they all work the same way. The idea behind their protocol is the same. It's just that, right? It's just like, well, as a company, of course, you want to have your own protocol, so you're not at the mercy of issues outside of your own business. Okay, that's normal business, I guess. Cisco point of view, if they don't have their own protocol, they have to follow the VRP. They don't have much say because it's a democracy. They have to consider everyone, because it's open standard, everyone is involved. So they implement their own proprietary, but at the same time, they don't want to shut out their customers who prefer multi-vendor. So they also support VRRP version 2, which is the open standard, right? Right. So the next slide, you can see others. So the more up-to-date version, VRRP version 3 supports both IP version 4 and IP version 6. Right, and it's because it's open, it's non-proprietary, it's open. That means it's the protocol that you want to go for if you're working in a multi-vendor environment. Means you have more than one vendor providing different brands. Okay, and because this is a newer version, it's more scalable. More scalable means I think it's easier to increase the backup routers, okay, to add routers to provide the redundancy. It's more scalable, so you need more how to say, more redundancy, then okay, you add more, right? You want to support I'm pretty sure, and later we'll see the VRRP version 3 also supports load balancing, because scalability is also mean that if your network grow, if your LAN grow, and there's no problem, right? Because of VLANs, okay? VLANs, then you don't have to work with too many. Remember in the first network course, we have to do subnetting. Subnetting, when you look at subnetting, it works on the real network, right? But when you start to use VLAN, you're not limited to do subnetting. You don't care really, because it's VLAN, it's virtual LAN, and it works on private addressing. In any case, if you provide more and more, your network grows bigger and bigger. That means one router probably will reach capacity. So load balancing becomes very important then. So we'll see whether the scalability, better scalability offered by VRRP version 3 actually includes load balancing as well. So you can see here what I'm talking about. Glbp, Gateway Load Balancing Protocol. Okay, this is again a version of a Cisco proprietary FHRP, right? That on top of providing features of Hsrp or VRRP, it provides load balancing, otherwise known also as load sharing. Okay, so let me make clear the distinction. between GLBP and the Hsrp. Hsrp, you want to provide redundancy. Okay, so you provide more than one physical router. Okay, but only one of the physical router will be running or active and providing the forwarding service for the virtual router at any time. The rest of the redundant routers will be on standby. They're not doing any work. They're on standby only. But they are ready to pounce when the main router, the active router, is down. The redundant router will, using a mechanism, will replace the down router, becoming active router, right? But to be scalable means if you add hosts inside your network expands, means there will be more traffic requesting to go outside of a LAN, right? So your router job, single router job will increase, so the load increase. Okay, and sometimes when it's saturated, when it becomes a rich capacity, nearly the capacity of the processing power of the router, because we don't see a very expensive kind of CPU in a router, right? I don't think so. I never hear about router CPU becoming like a server CPU, but it will be saturated. That means there will become a time that will be an issue. Okay, when the router capacity is reached in terms of forwarding, then of course latency will be introduced for the network. Whenever they try to, when the host try to communicate with host outside the network, especially internet. Therefore, for GLBP, right? And similarly for GLBP for IPv6, what happens is the standby routers are not just being idle. Okay, they are not just being idle. In this case, they will also take some of the load. Okay, that means there's load balancing, means try to be fair. If you have, let's say, two, so 50-50 of the load is taken up by the two routers, right? So let's say you have four. So on average, the best load balancing will be that because you have four routers, each router will take 25% of the workload. Okay, so if then you can imagine if one down, three still works. So the load balancing now shared among the three routers. So there's a slow degradation of service, but it will not fail. Okay, it doesn't straight away fail, but so there's, you can see, yes, become slower, right? But we still have the connectivity, right? So at the last one, the last row there, the Icmp router discovery protocol, IRDP, okay, and it's come from the request for comment document 1256. Okay, this is a legacy FHRP solution. There was an initial solution which has now been superseded by the newer one. So if this is RFC, so I think this is open standard. That means IRDP has been taken over by VRRP version. I think the latest version is 3, right? Okay, so how did IRDP works? IRDP works by allowing IPv4 hosts to locate routers that provide IPv4 connectivity. That means there is a protocol that the host itself do the job of finding out if just like you can think like a DHCP, I guess, DHCP or DHCP or DNS. That means if let's say you have your host have got IP gateway IP address, Okay, so to find out what is the gateway IP address, then you go and query. The thing is, this type of how to say this? This type of solution generates a lot of traffic because every host will do the query, right? It generates a lot of traffic, and this traffic is, I will imagine, because you don't know where it is, you're sending to everywhere. Okay, just like NLP, right? You're sending everywhere because you don't know. Is there any router? So if the router is not reachable anymore, then we restart the process. Is there any other router? Right? So this is very expensive in terms of maybe saturating our LAN with broadcasts, right? Broadcast packets. Okay, so it's not very efficient. So rather than the host, the new implementation, rather than the host itself, like querying the network, okay, we'll just provide that solution just now I explained. It's a more elegant, simpler solution, and it's scalable, right? It's scalable. Okay, with the load balancing, even make it more scalable. All right. So, any questions so far?
No.
So far, no.
So far, no. Kelvin?
Okay.
Okay. All right. Actually, I'll just move to the second section. So we actually look at FHRP. So in general, that's why we also look at the non-proprietary version, the load balancing version, right? And how this, but we have seen that the Cisco provide their own version, which is Hsrp. So this next section, we're focusing on the Cisco implementation, right? The Hsrp, right? Right. Okay, so let's look at overview for Hsrp. We already know that we have two versions, IPv4 version and IPv6 version, right? And we know that functionality is that to prevent any downtime for your network in order to access internet or outside of your LAN, okay? Right, so that means there's redundancy available for your gateway router, right? So Hsrp is Cisco proprietary protocol, right? And it's transparent, failover. The keyword is very important because there's nothing to do by the administrator. Don't need to do anything. The hosts don't even realize what's happening. It's a transparent process. Okay. Right. So another keyword ensures high network availability. Meaning to say, it's very crucial to have this feature in your network. If one of the requirement for your network is that it has to be up all the time, no downtime, right? No downtime, because especially nowadays with every worker now working from home, right? Working from home, and so when they want to access the their intranet, they have to you know they we work basically from everywhere. So all your can imagine the organization now. Used to be, if you're not in pandemic mode, you're working within the network. You are at your your office computer is in the same LAN. So if you say you don't provide internet connection, it's still okay. You can still access because you're inside the LAN. You're inside the office LAN. You can still do your job because you can access the company's computer systems, computer networks. But once the pandemic comes in, I'm just giving an example. Then you start to have your employees outside of your network, maybe linking to your network via your gateway, right? By using, okay, of course, secure connection like VPN. But now, right, if your gateway fails, then no work can be done because all your employees working from home, suddenly that becomes issue. So suddenly now your network must have high network availability. Means you have to have the gateway there. You have to configure this kind of situation, isn't it? Yeah, right. Previously, maybe not high concern because all your workers at the office, all your workers behind your own network. So the gateway not so much an issue only for those who need to go out, right? Go outside the network. But you flip the usage of your network, huh? Okay, when people start working from home, they want to access company services, computer services, they have to go through the company's gateway, right? All right, so Hsrp protocol is the protocol is used in the group of routers. Means we say group of routers because we want to provide redundancy. Means we have more than one router. Okay, and there is a part of the protocol that allows the router to select which router is the active router. Right. So once you selected one active router, the rest become standby routers. Right. Okay. So in a group of device interfaces, the active device, the active router that was selected, okay, will be used or will be providing the routing functionality. Okay, because routers still do the same thing. Even using Hsrp, the main purpose is to forward, right? Forward packets. It's just that now, among all the routers available, which one of you are doing the job? So you are the active router, right? Okay, so also when there's a failure situation, the active router goes down, the which standby device or standby routers takes over, becoming the active router instead. All right. Okay, so the function of this Hsrp, okay, standby router is to monitor operational status of the group, right? And to detect some preset condition, that means to indicate that, okay, it's down, the active one is down, then to assume the responsibility, take over the responsibility. And this is all done transparently from the host, right? So let's have a look. Here we delve deeper into the protocol. Now we are looking at something called Hsrp priority and preemption. All right. So while I'm explaining, you guys have a look at the diagram in front of you. The scenario that's given, right? So you can see the active router, standby router. Active router having a priority of 150. This is the example or scenario that we are given. And then standby router have a priority of 100. And then what the host see is the virtual router. Okay. And on top is the cloud or the internet network. And then virtual router is what the hosts in the network see. They see the virtual IP version 4 address, and they see the virtual MAC address. Okay, and these are the two addresses are the ones that is going to be, well, as a network administrator, you use the virtual IP version 4 address to configure as a gateway address on the host, right? But hang on, why is this? Oh, come back here. But the virtual MAC address is not configured. Of course, that is after the ARP, your ARP table should have that mapping between the virtual IP version 4 address and the virtual MAC address in your the host ARP table, right? So you can see the priority being used here. So let's look at it further, right? So who becomes which router becomes active or standby is determined by something called Hsrp election. So by default, which router has the highest IP version 4 address is elected as the active router, right? So meaning for the interface, which one is higher, right? Highest IP version 4 address. becomes the active router, right? Well, because the priority by default is 100. So if you leave the default Hsrp priority of 100, so all your candidate router same ranking, okay, priority is same, okay, if you leave it default. So if it's the same, you need to break the tie, meaning the protocol will look at the interface of each routers, which one is higher in value, right? So usually, if this is 100, this is 100, then this one wins. So this is the active, this is the standby. But it is always better to control how your network operate under normal condition rather than leaving it to chance. If you leave it 100, even though probably you are the administrator to assign the IP address, but still considered as leaving it to chance, because you let it go one step further for the election, right? Okay, you let it, because there are two steps, right? Priority is look at first. If they are equal, then they look at the protocol, look at the IP address for the interface of the active the router, candidate router. Okay, not to mention the extra, well, maybe it's minuscule, but it's extra processing to go from checking the priority, then okay, so all routers then checking the secondary value, which is the value of the IP address. Okay, better if you already have your topology like this, you're the administrator, you probably would say, oh, okay, let me determine. So when you determine, let's say I want R1 to be the active router, so then I set the active this R1 priority to the Hsrp priority to 150, right? Okay, so then once the when you set that, then it becomes the what lah, right? So you no longer need to depend on the secondary comparison, which is the numerically highest IPv4 address, right? So you can set HRP priority 0 to 255, right? And it's we actually on inside the iOS, it's actually called standby priority, right? And then the range of these HRP priorities set between 0 to 255, with 100 being the default value. Okay. So if I want that to be my active, so I put 150, which is higher than 100. So this one wins. This one wins. So even though the standby router here has a higher IPv4 value, but it never checks. It never gets checked because that is a secondary, just to break the tie, right? Once the election is won in this level, which is the Hsrp priority value, then there's no need to go to check the secondary election, which is the IPv4 address. Okay, so it's better for you to configure it yourself. Just leave the rest to be 100, and then you just, unless you also want to say, okay, if this active router down, I want that to be my standby router, then you adjust the priority accordingly lah. You sort the priority according to which router you want to take over to be active router, and so on and so on. Right? Okay. Yeah. Right. So by default, after the election, that means the router already becomes active router. it will remain to be the active router, even if you add another router to the Hsrp group, right? When you add in and it has a higher Hsrp priority, you will expect that, oh, okay, that one has higher, so then it will take over, become active. No, it's not done. It's not going to be automatic like that. If the router that's already active router will proceed to be active router, even you add a new router with higher Hsrp priority, right? It cannot automatically be determined. You have to do it manually. Okay, this is the point of the next point here. It says to force a new Hsrp election to take place, right? You must allow preemption by using the command standby preempt interface command, right? Preemption is the ability for the router, the Hsrp router, to trigger the re-election process. With the preemption enable, a router that becomes online with a higher priority will assume the role of the active router. So you must do this extra manual process. So let's say the only reason why you want to put a higher priority for the new router you adding to the Hsrp group is because you want it to be active. So if that is your intention, so set the standby preempt. If it's on, right, then the moment you add, it will trigger that router will trigger a new election. Of course, because it has a higher Hsrp priority, it will become the new active router. And then what happens to the old active router is just delegate back to standby router. Okay, but of course, the standby preempt is only to trigger election. Elections still need to be done. Just in case the new router you add actually does not have a higher Hsrp priority, then if that is the case, it will still not become active router. Still if the currently active still has the higher priority, then it will remain to be, after election, it will remain to be the active router, right? So it's only triggering re-election, but the election still runs, and during the election, it's still to determine which of the router, active, standby, and new router, has the higher priority. Okay. Okay. So please note this one. A router enabled for preemption, standby preempt, with equal priority but higher IPv4 address will not preempt an active router. So the secondary election will not be used to preempt. We know already that at the beginning we say we look at the priority. If it's equal, then check secondary election, which is the IPv4. But if you're introducing a router using standby preempt, right? You add on, you plug in, and lo and behold, their priority the same, right? The secondary election will not happen. Once it's the same, the active router remains the active router. Okay, only through this case, standby preempt, right? Okay, so another case. If the preemption is disabled, the router that boots up first means it's a race. I switch on my router. So which one will boot up first? Okay, because at the time that it boots up, it will be the single router. The rest not finished booting up.
Number 15. Muggles had code damage.
Right? So yeah, because when it becomes the active router, there was an election. Since booting up process may not be deterministic, maybe some delay, right? So if the active router happens to have an election when there's no other router, so by default it's the only one, then it becomes the active router, right? And since preemption is disabled, there are no more election happening after that. So if there's no election happening after that, then the active router is remain to be the active router. Can you see that? Can you see the kind of scenario there? Any question on that? Imagine you have four. Let's reduce it. Three routers. Okay, so you switch on. The first one to boot up, complete booting up, will notice that there is no other router, right? So when there's no other router, by default, it wins. It becomes the active router. But finally, the two routers boot up. Okay, they might have, if there's an election, any one of the two might have won because maybe they have higher Hsrp priority or higher IP version 4 address. But since standby preempt is not specified, means preemption is disabled, then there is no election. There is no election. The moment they join in, there is no election. So when there's no election means the current active becomes still remain current active. So this is just something that you have to be aware of, right? And if you're wondering, hey, how come I set already higher, but you didn't put standby preempt, means no election, and it depends race condition, which router boots up first will become the active router. Do you have any question on this part?
Or means the preemption is to allow re-election lah.
Yes.
Oh, okay.
Yeah. So this is a caveat when you switch on all the routers. Okay, and then there's no preemption. The router that boots up first will definitely become the active router, and that's it. No more. No election already, right? Even though the other two routers join in, no preemption means no re-election. So the current active router remains to be the current active router. The two other routers join in, even if you set one to be higher priority, or or they have higher whatever priority lah, because the preemption doesn't look at the secondary election, right? Then that means if that is not your intention in the first place, then you have a misconfiguration already. Okay.
Sir, based on the previous slide if the standby router take over as a active router does it still listen to the other router?
Yes. And because the new active router, right, needs still to it's not listen. You mean listen to hello messages?
Yeah, the hello message.
Yeah, I think because the roles change, that active router becomes the sender.
Oh.
Right? They changed role already from standby to active. So I think obviously that router is now the active router, is no longer checking for other because it's its own active router. So it should be informing other default routers. Oh, I'm alive. Hello. Once this active router, this new active router, not sending anymore, then it's presumed to be down. The other standby will take over again. And then, it's changing of role. So they depending on their role, they start to do whatever the protocols they take them to do. In this case, if the default router now take over the job as active router, I think it stops listening. It will send out the hello messages.
Okay.
All right, so here is the table to list out the states of the states available with the Hsrp, right? So initial state, learn state, listen, speak, and standby, right? So just now the one we talk about is the listen state and the speak state, right? So we'll get to these two, but initially this is a state when the router goes into configuration change, right? When the interface first become available. Okay, initial means just possibly just checking interface or correct configuration or not. And then the learning state, the router have not determined yet what is the virtual IP address. Okay, and also have not received any hello message from the active router, right? So in this state, that router has no idea what's happening, is waiting to hear from active router. Okay, then let's say the router now have the virtual IP address. So at least it knows the virtual router's IP address, but the router is still not not having the knowledge whether it is the active router nor the standard router, right? It's still listening for hello messages. Okay, listening hello messages. So and then the state of speak, that router is sending periodic hello messages. Okay, and if there is a election, it will join the election. Okay, to whether who to determine who is the router, or which is the router is the deemed to be active or standby router, right? So standby state is that the router is the candidate to become the next active router. So basically, but it's not doing any routing task lah. It's just waiting there, right? Okay. Router is candidate to become the next active router that sends periodic hello messages, right? So the active router sends periodic hello messages. Now you can see that my mistake, I said it's only the active sending the hello, but standby also sending hello packets, which means this hello packets is generic to inform and I think probably inside the packet they have different info to indicate whether they are active or standby routers hello packets, right? So this periodic here by default is 3 seconds, right? Standby router will become active if it does not receive a hello message from active router. Now the thing is, I'm pretty sure, okay, the hello packets are different for both active and standby, and thereby the standby router can differentiate the hello message it received is actually from the active or another standby router, right? So the time to decide whether the standby router transition to become an active router, right, is 10 seconds, right? From the time it last received a hello message from the active router. Okay, now these two are configurable, 10 seconds, 3 seconds. Okay, but you also need to make sure that you don't set the hello timer below 1 second or the whole timer below 4 seconds. Why? Because the timer also take up the resource of that router. Okay, so you don't want the router to be excessively doing this Hsrp thing, because it still need to do the forwarding thing, the forwarding job. Okay. All right. So let's. So this is the last slide for Hsrp. Okay. So the next section is basically module practice and quiz. Again, you have the chapter exam inside the NetAcad to just provide your revision practice, but they also probably some packet tracer exercises there, right? Okay, so what did you learn in this module? About redundancy, providing gateway redundancy, right? So the current way, okay, to do that is providing virtual router. With virtual router behind it, there are multiple routers, okay, using the FHRP, okay? They work together to provide the illusion of single router. The illusion here is illusion towards the host, okay, inside the LAN. They don't see any difference lah. You just configure them with that single IP version 4 gateway address. That's it, or IP version 6 gateway address, right? So to them, it's like usual, right? So the redundancy protocol allows the standby router to become the active router in the event that the active router is down, right? So what's the difference between active and standby? In our case here, we're not looking at load balancing. Therefore, active router is the router that is performing the actual job of the virtual router, which is forwarding packets, right? Standby router, okay, just standing by. That's why the name standby. Just standing by, simply checking whether the active router is still alive or down, is still online or offline. The moment the active router becomes offline or fails to send hello messages to indicate that it's still online, then the standby router, after 10 seconds by default, will transition itself to become the active router. Okay? Right. These are the steps that will take place when active router fails. The standby router stops seeing hello message from the active router. Then after 10 seconds, as the default value, excuse me, the standby router assumes the role of the forwarding router, meaning the standby router becomes the active router, right? Since this happens transparently behind the virtual router, excuse me, then as far as the host devices are concerned, there's no change in the IP version 4 and MAC address. Okay, so it's business as usual for them. They don't see any disruption, right? Okay. Okay, so here is just a comment. That means this protocol used in production environment. What is production environment? In real world environment, actively in support of the organization. That means it's not it's already deployed. This is the one that is used by the employees of the organization doing the daily work, right? In production environment already. If something happened there, it will affect the business, right? So that's why, of course, we want to protect that production environment. We want to protect the network. Okay, we don't want to disrupt any of the business workflow that involve the use of the LAN. That's why we use this protocol. Okay, and how many routers you want to provide? Which LAN you want to protect by using this? All depend on the organization needs, right? Maybe for the low impact, non-critical part of the organization, that maybe it's okay, right? We don't have to provide this kind of redundancy. But maybe for the sales part, or the one that maybe have a transaction, okay, point of sales, whatever, where you cannot have disruption, then you may want to put this redundancy facility in the network lah. Okay, think about okay, let's say supermarket. Okay, your point of sale operates in a LAN, right? And your point of sale is accessing, because you're one of the branch, so your database is not local. Your database is in the cloud. So any of the branches will have to access the cloud to access your database, right? You're a large supermarket, not just the small ones, right? So that means your connection outside of your own LAN to the cloud needs to be good, no disruption. Because why? Because maybe your supermarket is a busy kind of supermarket. You're scanning it. Your ability to go to the cloud to retrieve data from your database allows you to perform the point of sale, point of sale calculation, the cashier part of your supermarket, the cashier functionality. So in that case, I cannot imagine when it's down, then suddenly people cannot pay lah, because there's no way to retrieve unit price by scanning, right? Simply unthinkable. So for this kind of production environment, this is this way to determine that you don't lose the connection to that means your gateway always on. Means this is a very good way to implement that. All right. Right. So there are other options available for FHRPs. The first one is the Cisco version. There's one for IP version 4 and one for IP version 6. The open standard version is FHRP version 2 and version 3. And then the load balancing option is GLBP for IP version 6. Okay. The LB stands for load balancing lah. And then RDP is a legacy. Icmp for routers lah, right? So that is a legacy. That means it's an old technology. It's an old protocol. So usually it's no longer supported lah, right? Okay, and then we talk about transparent failover because of the usage of the virtual router, right? We talk about active device, standby devices, and then we talk about the election involving Hsrp priority. That's the first election. Secondary election is the if the priority are equal, because the default is 100. If you don't change it, it's equal. Then the tiebreaker is the IP version 4 value. The higher one on the interface of the router wins, right? And the states for Hsrp includes initial, learn, listen, speak, and standby. Right. So in terms of packet tracer exercises, the exercises I think is okay lah. Because there are not many commands to use. Okay, so it's to configure Hsrp active router. How do you configure? Because if you don't configure, right, if the Hsrp is running inside the router, by default, all priority will be equal, and the secondary election will break tie, so you're not involved. But if you want to configure active, what do? Means you select which one is the active router, change the value and set it higher. Value of the Hsrp priority from default of 100, change it to higher. Okay, example 150, and then you are ensuring during the election that router will win the election and will become the active router, right? Okay, and then configuring Hsrp standby router, verifying operation. I think verifying Hsrp operation very easy. Okay, switch off the active router. After 10 seconds, roughly, if is default, then you should see that the gateway processing, that means forwarding, still works. Then you can check the router, the standby router, is it now becoming the active router? Okay. And that's it. That's our today's lecture. Okay. Any questions so far?
No.
No.
All right. Okay, so I've already so we still have about half an hour, and I want to go into a new topic, right? Because because this is a short one, right? And not many configuration for this one. So let's just go to our cost plan. Just share the cost plan with you. Okay, so cost plan for this week 4 is only to cover this chapter 5 ether channel and chapter 6 FHRP concept, right? And only next week we'll start to work on a couple more topics: basic routing and LAN security concept. Okay, so I don't want to go into that yet. We'll wait for that for next week. In the meantime, right, what you can do if you take a break in the meantime, take maybe 5-10 minutes break. But I've already prepared for you the tutorial. Okay, we have 2 tutorials since yesterday. That you guys do some revision. Hopefully, it was productive for you. Yeah. There is a tutorial 5 based on ether channel questions. Okay, and the second tutorial is tutorial 6 FHRP. Right. So let me just stop this one. Just show you. It's already shared to you. Yeah. 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 These 2. Yeah. So this one is the ether channel, right? Based on yesterday topic, not many questions also. Go ahead and you can start doing already. After maybe if you want to take a break, it's okay also. And before you start on it, I also have this other one. Okay, so which is today's topic. Tutorial for today's topic. Right, which is on FHRP concept. Right. 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 Okay, so take a 10 minutes break and then you can do the tutorial 5 first before trying out the tutorial 6. All right. Have any question? Let me know. I'll be monitoring our chat here. Let me stop my recordings. Is that okay, guys?
Okay.
Right.
Okay.
Okay.
Yes, Noel.
Sir can have another consultation this Friday.
Same time.
They were clashing with the student dialogue, so maybe 12 o'clock.
Oh, okay, ya kan, betul. So you wish 12 o'clock, huh?
Oh yeah.
Okay, 12 to after the consultation, huh? 12 to 1, yeah?
1. Okay.
12 to 1, yeah?
Okay.
Okay, 12 to 1. Okay. Okay, created meet and at 12 to 1 Friday, this Friday.
Okay.
Okay. Right, so everybody, we continue with the other meet, tutorial meet, yeah?
Okay.
Okay, I'll see you guys there, the other meet. Right, so Ferry, you still on tutorial 5, question number 3, yeah? The question is which mode configuration setting will allow formation of inter-channel link between switches, switch 1 and 2 without sending negotiation traffic. So negotiation traffic is initiated by using the protocol PEGP, PAGP from Cisco. So without negotiation, it means you can use the manual method, which is using the on. Okay, the on. Are you stuck there? That means you put as a channel group, let's say one mode on. So the mode is on for both. Then if you use mode on for both, then the ether channel link is created without having to go through negotiation traffic. Yeah. Is that okay, Farah?
Oh, so
That means both. Yeah. That means both side of the link on the switch 1 and 2 has to be set to mode on. Then you can create the ether channel link without any negotiation traffic. right? The other two is auto or desirable. Auto or desirable make use of negotiation traffic, which is PEG-P lah, PEG-P. So it says here, the question is without sending negotiation traffic, means we have to do it manually. So the manual way is to set mode on for both switch 1 and 2. Is that okay?
Okay.
Yeah, I'm talking about tutorial 5, question 3. All right, so for Kelvin, number 5, part 1, it says that, let me just show the tab. Okay, so Kelvin, your question is 5 part 1, refer to figure 1.2, which is this, right? Switch 1, switch 2. You have two link between the switches. Okay, you want to create ether channel, but it says that PEG-P ether channel is not created. So in fact, because we notice PEG-P, right, means we want to use the negotiation protocol. We don't want to use on, right? So, but when we say show run on switch 2, it shows that mode on is configured on FA1 and mode auto configured on FA5, right? So FA1 is wrongly set, okay? When we put set on mode on, since we want to use PAGP, we can assume the ports should be using PEG-P, right? The fact that on does not receive or does not send negotiation traffic means that's the cost. That's the cost, which is correct. It says that you say the on mode mainly, right? But it's only partial answer, right? In order for the you have to explain further in saying that because it's PEG-P, instead of on, what should it be set to? Right, since the partner on switch 2 is auto, right? Okay, so if it's auto, then you cannot mix, yeah? It means if all the link that is participating in the ether channel, if you say you're using PEG-P, then they all must use PEG-P lah, right? If I set on, then all must use the non-PEG-P. But since mode on is wrong, right, as you indicate here, so that's why your answer is correct. But additionally, you must say that you can continue your answer. Since it's not on, that is incorrect. What should be there? Since the partner on switch 2 is F5 is auto, so what should be the one on switch 1 so that auto works? Means auto only works if the other one is desirable. So you either if you set auto and then F1 instead of on, you put auto as well. So on switch 1, both F1 and F5 on switch 1 should be set to desirable. So desirable, then the auto will negotiate. Okay, so you should specify extra info like that. Okay, right? So if you set auto and switch 2, then on the other side is desirable. If you set auto desirable, then you can have desirable or desirable auto, something like that. Is that okay, Kelvin?
Okay, but
yeah, you
okay,
just
the second,
expand.
but
Yeah,
the second the second question asks us to explain how we fix it, isn't it? So first, do we still need to explain at the first question? The second
Yes,
one, we
because
just set
the
it.
the second question is not limited only to the PEG P.
Oh,
Yeah, it's not limited to PEG P. So it says suggest two settings. Two settings that must be identical on both ends of the connection for the ether channel. Must be identical. Means it no longer only focus on PEG P. So you can say either, okay, I just give you the other possible answers for part 2, right? You can say that both connection must support ether channel, although it's obvious, but there are some from other vendors, some other switch does not support ether channel. So you can say both ends of the connection must support ether channel. Secondly, both ends, the speed and duplex setting must match. Okay, so that means the speed cannot mix and match, and duplex must be a full duplex, right? The both ends also the VLAN must match. So it means all interface are in the same VLAN, right? And the range of VLANs, okay, all same range for all interfaces. Okay, means there must be both and equal, right? So these are the other settings that must be identical on both sides, right? So your answer that you're given here is actually part of the answer here, the PEG-P configuration. Okay, you can put as part of the part 1 answer, and the second part answer you can choose any two, ether channel, speed and duplex, VLAN match, or range of VLAN. Okay, any two out of these 4 options. Is that okay, Calvin?
oh, okay.
All right, so number 6.
The second question, so the answer is
Either any two of the lists I give you are ether channel, speed and duplex, VLAN must match, and fourthly, range of VLAN. So because the question asked for 2, so any 2 out of the 4.
oh, okay.
Okay. All right. So Noel, on 6 part 1, I made some comments there. The main thing about it is that there is no negotiation. So you shouldn't put your answer negotiates, because in fact auto means it's listening only. There's no negotiating happening, because it's not sending any negotiation packet. It's not sending any negotiation requests. It's just listening. Auto is on listen mode. So you said there negotiate is a wrong keyword to use Okay. You should say they are listening. Okay, both end is listening. Six, 2.
Oh, the question 2, I answer like how the S1 on and then S2 on or something, or I
Your answer. Wait. Question 2. Question 5 is it?
question 5, yeah.
Part 1 or part 2?
Part 2. How you answer? Do you write?
Oh,
you answer
yeah.
like this?
You just mention. Let's say you choose ether channel. So you said that both, because it says both ends are of the connection, right? So your first answer can be both ends of the connections must support ether channel. And your answer in part 2 right now is correct, but it's for the second part of part 1. Okay.
For second
And
part of part one.
yeah, because that's incomplete. And your answer is with the on one is incorrect. We don't want on, that is manual, because the question already said illustrate why PEG-P is not created, right? So that means the intention was for using PEG-P. Yeah.
Okay.
Yeah. So either you use, right, if you both auto means on the other part is what? Must be desirable, right?
Yeah.
Yeah.
Desirable
So
auto.
no, because you put both auto. This is what
Oh,
this switch to, right? Auto means the other switch must be desirable.
yeah.
Yeah, because they must be complement each other. On opposite ends, you cannot have auto because they're both listening, which is exactly what happening at the 6 part 1 for novel. Auto means both listening. There's no initiation for negotiation. So it either desirable or desirable auto. Okay, for both ends of the switch of the link. So your answer for this, place it as the second. Continue the answer in part 1. Okay, you just move it over to the other. Yeah. Okay. And then indicate for which interface is for which switch.
Oh,
Right. So switch to auto. So switch 1 means you have to put, let's say, either that means auto already. So switch 2 means switch 1 is desirable. Yeah. So this is one way to fix it, lah. Yeah.
then this part how to answer
Yes.
again.
I said there are 4 options: A2 channel, speed and duplex, VLAN match, and range VLAN. Let's say you take the first 2. So you answer like this. So both ends of the connection must support Ether channel. Okay, that means identically both ends must support Ether channel for Ether channel to be created. Okay. Okay. And second one, both ends uh, uh, both ends of the connection speed and duplex setting must match.
Okay.
Speed and duplex setting must match. So you cannot mix fast Ethernet with gigabit, for example. You cannot have half duplex with duplex, right? Must be identical. One side full duplex, one side full duplex. Okay. The
Okay.
speed, one side fast Ethernet, the other side must be fast Ethernet, like 100 megabits, 100 megabits. You cannot like mix gigabit and fast Ethernet lah.
Oh,
Yeah.
okay.
So we only list 2 because of question say 2, right? The other 2 is the VLAN range must match, and the VLAN interface must be in the same VLAN. Okay. The other 2 option.
Oh,
Okay.
okay.
Correct already. Fairer answer is correct now. You indicate that on. Okay. The reason why we choose on because that's manual. Okay, and it is done without sending negotiation traffic. That's the hint why you should use on. Right.
Okay.
Yeah. Right. So for Noel, negotiate, maybe you should replace that with listening.
Oh,
Yeah. Instead of negotiate, because there's no negotiating happening because both are listening. Yeah. They're both listening for the other one. Right. So just, I think delete that negotiate. Negotiate only happen with desirable. Right? The desirable port will send the negotiating packet. It reach the auto respond because it's listening. Yeah. But if both auto, no one is sending the negotiating packet, therefore, no matter how long they listen, they don't initiate. There's no packet to tell them to start up to negotiate setting up the ether channel. This one is 6.2. 6.2. What would you suggest to correct the issue in question 6A, requirements to use PEG-P? Your answer is Noel. You can't use on because on
oh,
is
the one
manual.
is
Yeah,
manual,
it's
right?
manual, no negotiation. The question asks you if you're using PEG-P, which is negotiating, right? Can you change your answer? Remember, guys, when we say for ether channel, when we put on mode on means no negotiating is happening at all, either sending negotiation packets or receiving or listening, not happening. Okay, on. Okay, the moment the question mentioned PEG-P means negotiation setting is preferred. So that means either you use desirable, or desirable auto. Okay, I'm talking about both side of the link lah. Desirable, or desirable auto. Just ensure there's no auto setting. Auto setting means no. No ether channel will form. Can either put a partner like desirable, or desirable auto. Then ether channel can form using negotiation. So in order to fix this, what should we do? In order to fix this, after this information show, ether channel summary show, begin interface port channel, we see, do we see anything wrong? So switch 1 is auto, switch 2 also auto. Will there be any negotiation?
No.
No, right? So what should you do? You should change it to like on switch 1. If you put switch 1 that desirable, then switch 2 can be put as desirable, or what? Desirable auto. Okay. If switch 1 is desirable, then you can either put desirable, or remain it as auto, and vice versa. Because auto here and auto here, no negotiation happens. Ether channel cannot form. Okay, it's either this switch, both link you put desirable. Therefore, it will send packets, and then switch to listening, and auto will listen and negotiation will happen. Then ether channel will form. Okay, this is one possible correction you can put. All right. So normally when you want to do correction, okay, means okay when it says what would you suggest to correct the issue, so you should key in or type in the command to correct. So to correct, I believe you can just do correction here lah. So the step by step is, first remove the interface port channel. Then select the interface range, which is what interface? Yeah, F1 to 2. Then change the channel group 1 mode desirable, because right now it's auto, right? And then bring up the interface back. Just now you said no interface, right? So bring back the interface port channel 1. Okay. Configure it to be mode trunk, right? And then that's it, right? Okay. Since if you set here as desirable, let's say that one I highlighted, means if F1 to F1, right, then this one desirable, it should form with auto, right? And then if you do the same changes to interface fast Ethernet 2, make this desirable, then there's no need to change here lah. Okay, means desirable and auto here will form the ether channel. Okay, or you can decide to put everything desirable. So change here desirable, 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 desirable. Okay, is that okay, Noel?
Okay, maybe.
Are you okay with this? Do you get what I'm trying to say?
Yeah, just that the comment lah. I still not sure.
Yeah. Okay. Okay. Right, so I move on to 7 first. 7. So fairer. Ether channel was configured between switch 1 and 2, but the interface do not form ether channel. Identify and rectify the problem. Justify your answer. So let's say S1 and S2 configuration. Interface 0 and 1 on S1. Channel group 1. Mode active. So mode active is using the open standard version, not PEGP, but LACP. Right? For LACP, because of the keyword, the command, you straight away know. Remember, Cisco supports both its own proprietary, which is PEGP, and the open standard from IEEE, which is LACP. For PEGP, the mode here, you can either put for negotiation one, you can either put desirable or auto. Okay, but when you see active, right? Active means it's the LACP. Okay, no problem, because the switch, the Cisco switch definitely support that. Active have a similar meaning to desirable. Okay, active same as desirable. Auto will be passive. So since it's active, right? So that means both active, they should negotiate lah. But it still doesn't form, and we are asked why. Why? If you notice, and Farah already answered correctly, that the switch 1, the range is 1 to 5 and 10. VLAN 1 is supporting to transport. The trunk is support. Again, these are trunks supporting to transport the VLAN 1 until 5. So 1, 2, 3, 4, 5. Because dash means a range, 1 to 5 and 10. Whereas switch 2 misconfigured, right? It's either one will be misconfigured. It's actually because it's instead of dash, it's comma, means it only support VLAN 1 and 5 and 10. So misconfiguration. What is the rule? Both must be the same. Okay, either this setting 1-5, 10 is must be set here in S2, or the S2 1, 5, 10, if that is the correct one, must be set in S1. Right? So Farah, your answer correct. An Ether channel was not configured with the same allowed range of VLANs on each interface. Right? So that is correct. Okay, so you can highlight it also. Okay, to say that the VLAN 1-5.10, 10 is not the same as VLAN 1,5,10. Right? Just as additional confirmation. So rectifying, guess Vera, you identify, but what is the solution? How do you rectify? So you have to answer. So whichever you choose, either this set to here also, or this set to here also, as long as both the same. So provide one solution lah. Maybe for the justify your answer, you can just say VLAN 1-5,10 is not the same as VLAN 1,5,10 here in the justify answer.
Oh, okay.
Okay. All right. Noel, no, don't forget here. No shutdown. Bring it up.
Oh,
Okay, so all this correct. Oops. This answer, can you provide the alternate command? Alternate command? Okay, already, but can you like give the example command here?
Oh,
Like,
need the command also?
yeah, switch port trunk allowed. Maybe you, let's say you want to use S1, the S2 you put switch port trunk allowed VLAN and copy the S1 VLAN. Just provide the correct command there.
Oh, okay, okay.
Want to ensure in this way you can ensure to get maximum number of marks allocated lah. Right. Thank you, Farah.
Like that.
Yeah. So continue on your second answer, you justify. Remember, just say that the two you said VLAN 1-5,10 is not the same as VLAN 1,5,10. Yeah, that is explicitly saying that you understand what's wrong.
Oh, in the ether channel, the VLAN also must be same in both switch.
The what? Sorry?
The allowed VLAN.
The allowed VLAN, yes, must be the same. Must be. This is actually an option option answer up here. Okay, so Kelvin chose 2 out of 4. The other 2 is about VLANs lah, the VLAN range and the VLAN that the interface are in, right? So yeah. Yeah, correct. So like that, you answer like that, and okay. Right, so I think we completed this part. Any questions here? I think we covered all, right? Yeah.
Oh yeah.
Yeah. All right. Okay. So okay, that one is okay already. Then we look at T6 lah. Tutorial 6. Now, tutorial 6 is what we have just done earlier on, okay, today. It's on FHRP, okay, the redundancy of the gateway, the router, yeah. Okay, so what is the limitation default gateway? Noel said if a single router that contains default gateway is down, the end devices within the same LAN is unable to connect to a network outside the LAN, which is correct. Exactly the right answer. What is the mechanism to overcome a single point of failure at the default gateway? Router redundancy. That's correct. Technically, that's correct answer. But to show that, I mean, we want, like, remember, we always want to go for maximum marks. So we provide more. Okay. So what is the protocol? So because not mentioned whether it's open standard or proprietary, so we go for to actually say the exact name. Okay. So Kelvin, for number 2, maybe you can improve your answer by saying what is that. So that the router redundancy is the FHRP, right? First hop redundancy protocols.
Oh.
Right, and then explain what is that.
Oh.
Yes.
Okay.
Yeah. Okay. So you explain in a little bit more detail what is the first hop redundancy protocol. Okay, how it works. Okay.
Sir, for question 3, do I need to explain each of the options?
No, because it says list.
Oh, okay.
If list means you only list. If they want you to explain, list and explain, or list and discuss, or list something else. Okay. List, name, state, all this, just provide a list. Okay. This is the keywords that you, as students, should pick up already lah. Okay. Yeah, that's correct, Farah. Just list out the FHRP's options. I'll wait for you to finish that. Okay. Thank you. Good. This actually is a good way to answer. Okay. Ferrer has listed out not only the acronym but also the full name, right? That should always be like how you should answer. Okay, but you only have to provide this the first time. So because indicate that you already know, right? So you show one time, and then subsequent, then you can just give the acronym. Okay, so all right. So Kelvin, remember if if you're providing acronym, give not only the acronym but the full name, and then you just bracket the acronym. Okay. Especially like FHRP, then to have a complete answer, provide the full name and then bracket the acronym. Right? Can you also expand on your answer um, to include a little bit the detail? How does the two or more routers work in terms of
need more detail.
more detail? Yeah, this is so that you get used to answering in more detail. Okay, so when a test or exam comes in, right? I know that you are limited in time, but if you get used to it, then you might do it faster, right? Because you put yourself in the examiner point of view. They want to give more marks, but if they see the answer more details, mean they can justify more marks to give, right? And just give you some tips.
Is this enough or still need to add the more?
Yeah, okay, good. Yep. Can you also provide the full name here? Full name, then bracket the acronym. What is FHRP?
Oh, okay.
Yeah. And then you bracket the FHRP. Right. Now, this is nice. This is good answer already. Okay, so let's look at this. With reference to this figure, answer the following question. So here we have R1, R2, and I assume cluster 0 is basically the inter-network, and PC1, PC2 is inside the same network, and they have redundancy. They have two routers. Okay, so this is configuration for uh, the Hsrp. Yeah, you can see the priority is given. Okay, and you can see the actual IP address of the interface there, but the virtual IP address is there. Standby 1. See, standby 1, and that one, standby 1. See, it points to this highlighted in yellow is the virtual IP address, virtual router IP address. And notice the priority. So in the case of election, okay, which one will win? Definitely the higher priority, right? Okay. In the case of priority are the same, then we have to look at this. Okay, 10112 or 10113. The higher one wins. Okay, so if we have to go to second election, router 2 will win. But since in the first election, which is priority, router 1 already wins, so we don't have to check the second election, which is the IP address. Notice that standby 1 preempt here, standby 2 preempt here, right? In case of standby 2, okay, then you notice that the IP address is that, and priority is this, right? So basically, we'll look at these settings. Okay, what is the IP address assigned to R1G1? So R1G1 is that IP address, so that's correct. Okay. B, what is the IP address assigned to R2G1? R2G1 is that 10.113, so that's correct. What is the virtual IP address? Virtual is this one. So 10.111, correct. Right. Standby group 1 in R2, also the same. Right. R2, R1. Okay. Next, what E, right? Is the virtual IP address for standby group 1 in R2 and R1 and R2 must be the same? Must be the same. Or else, Kelvin, for part E, the standby group 1 in R1 and R2 must be the same because that is the IP address as for the virtual router.
Oh.
Yes, so must be the same so that when the second router takes over, it still use the same virtual IP address.
Okay.
Okay. Takes over as the active.
Active router, active gateway.
Yeah.
Active router.
Yes, active router. The IP address remains the same. I think the IP address of the virtual router.
Oh, okay. You need to explain this kind of, not just know only.
Yes, actually, but good also that you type. You know why? Because when you do revision later, you will see that you will see the answer there.
Oh.
Yeah, good for revision purpose later.
Oh.
Yeah. Right. F, what is the virtual IP address for standby group 2? Yep, correct. R1 and R2 the same. Must be the same. Is the virtual IP address for standby group 2 in R1 must be the same? Again, Kelvin, it must be the same, yeah? So that's the second virtual router.
Basically, same answer.
Yeah, so must be, yeah, same answer. Okay. Right, so part I, what is the default gateway IP address for PC1? So Farah answer 10.114. Where do you get that 10.114? That is the 10.114. Farah is the IP address for PC1. PC1's gateway address must be the virtual router IP address because that's PC1 gateway address. Since there are two virtual router, so you have to list out both virtual router IP address. So you can say either 10.111, which is the first virtual router IP address, okay, or 10.115. Yes. Yeah. Okay. The first one is standby group 1. The second one is standby group 2 because they are the virtual router IP address. Okay, and that that should be the PC's gateway address. Okay, the one the IP address beside the PC is the PC's IP address, not the PC gateway address. Right? Remember, when you configure a PC, you can specify the PC's IP address. You can also specify or configure the PC1 and PC2 gateway address. So where do you get the gateway address? Usually we get it from the router interface. But since we are using FHRP, means we use virtual router, right? So it should be the virtual router IP address. And in this configuration, the virtual router IP address is this and this. Okay.
Okay.
So that's your answer. So same with the EC2. Okay, Noah. Thanks. So going to K, explain standby 1 priority 150. Standby 1 has priority value of 150. That means the router 1 standby has a value of 150. A high priority value will be like that's the active gateway, correct? Okay. Right. So you should mention that this oh, anyway, standby 1 priority is here, right? Okay, so it's in router 1, so which means you can specify that it is on router 1. Okay. Explain standby 1 preempt. Right, so the preempt means the router with the high is always active if it's available. So it's the same priority, then the become active. But yes, that's correct in the terms. But preempt here means that router is able to trigger re-election process, right? So with the preempt, means this preemption is enabled. This router, if it becomes online, and if it has a higher SSRP priority, it will assume the role of active router. Okay, right. So this preempt means the preemption, that router has a preemption ability, which means it can trigger the active router re-election process. Okay, Farah?
Oh, okay.
Yeah.
So do I need to explain the preempt?
Yes, you need. Yeah, because it's part of it's a part of the keyword here, and actually because this is only means this is the virtual router 1, but that means this is the main thing of this this question. So you have to explain the preempt here. Okay, so you can say that preemption is the ability of this Hsrp router to trigger the re-election of an active router. Okay.
Oh, okay.
Yeah, and you can say if the router that comes online has a preemption enabled and has a highest Hsrp priority, it will after re-election it will assume the role of active router. Right. So basically, without the preemption, if you add a router, even though it has a higher priority, because there's no re-election, it does not become the active router. The current active router still remain as the active router, even though it has higher priority compared to the newly added router. But if you put preempt setting, when you add that router, right, it will start a re-election. And if that router that you add have a higher priority value, then it can take over as the active router, right? So that's why this preempt keyword is important.
Oh, okay.
All right, I'll let you answer that first, Farah, and then look at the last one, M. From Noah, what's the purpose of setting two HSRP standby groups in R1 and R2? Noah's answer, if the current active router is down, the other router with the highest HSRP priority will take over as a new active router. All right, so okay, here is where I believe the just now, I'm not sure whether it's mentioned as load balancing, but maybe it should be mentioned during the practical. Okay, so the answer, Noel, are you listening?
Yeah.
Okay. So the answer is configuring multiple HSRP groups on a single interface allows us to have HSRP load balancing. Okay.
Oh. Is it in the slides, sir?
It's not in the slides, so.
Oh.
I mean, not specifically mentioned in terms of HSRP, because the only mention of load balancing is Glbp. So that one comes with the load balancing. But this HSRP having load balancing means that you have two, in this way of implementing, you have two routers, two gateway routers. So some of it's manual, should say manual load balancing lah, because since you have two virtual router, right? And the virtual router means you have to specify some of the PC, okay, gateway address to the one group, one standby group, and some of the PC to the other router. That's why you have two IP address. Yeah, you understand, guys?
That's the answer.
Yeah, the answer is by configuring multiple HSRP groups on a single interface, HSRP load balancing can be achieved. Right? Preemption allows, okay, this is for Farah. Preemption allows the new router to become the active router if that new router has a higher priority. Preemption allows the new router to become the active router if that new router has a higher priority. Okay, yeah, Noel, yeah, correct. By configuring two HSRP groups on the same interface, one only interface, so no S. Yeah, on the same interface, load balancing can be achieved. Yeah, correct. Right, so Farah answer correct already. Yeah, right. And for Noel also correct already. Configuring, yeah, configuring. All right. Okay, any question? I also wonder why number M, Noel. I don't think this one is in the. Maybe you'll find these notes in the NetAcad resource online. Okay, please check. I will provide feedback to CC so that she can improve the slide later. Okay, for the next time. But I think this one definitely will be in. I remember this. Just didn't realize just now on the slide. but probably these notes available online on your NetAcad resource. Please do check, check your notes, because it's more details over there, and with more animation to highlight, and also sample commands for you to be able to to get more info. All right, so I think we covered all already. Yes, we covered all already. Any questions on this?
So far, no.
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 Okay. Is it clear after is the content clearer after you do the tutorial?
Yeah.
Yeah.
Yeah. Okay, that's good to hear. All right, so I see you guys later at 5 o'clock. Right?
Okay.
Yeah, join the meet. Okay. The Google Classroom will still use our current Google Classroom. It will activate. It will appear activate at the time specified in the what. Okay, so just join the meet. I think the meet is set for 5 o'clock, right? Yeah, half an hour from now. All right, take a rest before we do the dry run. Okay, dry run only. Don't worry about the actual test will be next week. Same day lah, Tuesday also. And I think same, if I'm not mistaken, it's same. Let me just confirm. Right, so I'll just activate this tab. All right, so this is the itinerary for later. Right, and next week, yeah, this is the itinerary. Okay, but this is next week.
Okay.
Later, we'll do this dry run, just a test. Okay, I'll see you guys later.
Okay, sir.
Okay.
Thank you.
Thank you, sir.
Thank you.